Good morning, students. So the next topic in chemical bonding that is also used to find out the percentage ionic character in a molecule, that is dipole moment. So in a molecule which have two different atoms, the more electronegative atom attract bonded electron toward itself and carry small negative charge, give another atom small positive charge. So what will we see here? That two poles are generated in a molecule. Hence molecule is said to possess electric dipole. It is called as a dipole as two poles are generated. So one more point here, that these charge are equal in the magnitude, as the whole molecule is electrically neutral, that is there is no charge on the molecule. It means the total negative charge must be equals to total positive charge. So now start the topic. Dipole moment. First of all, what do you mean by dipole moment? So it is defined as the product of charge on any one atom and distance between the centers of these two charges. It is denoted as mu. So mathematically it is represented as mu. It is equals to Q multiplied by D, where Q is the charge on any one of the atom. Taken the charge of any one of the atom, as both the charges are same, as their values are same. D is the distance between or we can say internuclear distance between two bonded atoms. Unit of mu, it is dB, denoted as capital D, which is equals to 10 raised to power minus 18 ESU centimeter. How? As Q, that is charge. If we discuss about the electrons, because this separation of charge, it is due to the electron movement, so it is the charge of the electron. So Q, that is charge of an electron, it is equals to either 1.6 into 10 raised to power minus 19 coulomb, or it is 4.8 into 10 raised to power minus 10 ESU. So Q is also expressed in the order of 10 raised to power minus 10. And about D, that is the distance, it is expressed, which is given in the question or numerical, in the order of 10 raised to power minus 8. So here it is Q multiplied by D, is expressed in order of 10 raised to power minus 10 multiplied by 10 raised to power minus 8, that is 10 raised to power minus 18, and units are ESU centimeter. ESU centimeter. So collectively this is called as 1 dB. Okay, so 1 dB, it is equals to 10 raised to power minus 18 ESU centimeter. This dipole moment, it is a vector quantity. It means it has direction as well as magnitude. Pointed out in a particular direction and also have magnitude. If we see the direction of dipole moment, then it is directed from less electronegative atom toward more electronegative atom. As suppose we have a molecule A, B, and A is less electronegative and B is more electronegative, then direction of dipole is from represented with an arrow, positive at the tail and negative on its head. This is the representation of dipole, which pointed in the direction of more electronegative atom from less electronegative atom. So now next one is applications of dipole moment. Then about its first application, it tells about the molecule, either it is polar molecule or non-polar molecule. How? If a molecule is polar, so now next is the applications of dipole moment. Then first application, to find out polarity of a molecule. Either the molecule, that is either the molecule polar or non-polar, that can be determined by dipole moment of that molecule. So the results are, if the molecule is polar, then for this dipole moment is not equal to 0. It means it has some value. But if molecule is non-polar, then mu is equals to 0. So let us now discuss the molecules one by one by increasing the number of atoms in them. So first, smallest molecules, which is consisting of 2 atoms, that is diatomic molecules. So these 2 atoms in these molecules may be same. If they are same, they are called as homoatomic molecules, and if they are different, they are called as heteroatomic molecules. So first, taken homoatomic molecules which have same atoms. For example, hydrogen. Here both the bonded atoms are hydrogen, hence their electronegativity is same. There is no charge separation takes place, hence no formation of dipole here. And if dipole is not formed, then for this type of molecule mu is equals to 0. And if mu is equals to 0, molecule is non-polar. Okay. Similarly, chlorine, nitrogen, oxygen, fluorine, bromine, these molecules are non-polar, as for these dipole moment is equals to 0. Now next one is heteroatomic molecules. Heteroatomic molecules which has different atoms, in which these 2 atoms are different. Homoatomic, diatomic, and heteroatomic in diatomic molecule. For example, HCl, here hydrogen and chlorine bonded, in which their electronegativity difference is different. So the more electronegative element attract the bonded electron toward itself, hence carry partially negative charge and give other partially positive charge. It means formation of dipole takes place, and the direction is from less electronegative to more electronegative. Okay. For this type of molecule, mu is not equal to 0. They have some value of dipole moment, hence this is called as polar molecule. Similarly, for HF, HBr, HI, all these molecules are polar in nature. Now the question is, among these hydrohalides, which has high dipole moment. So as we know, HF, HCl, HBr, HI, dipole moment, it depend upon 2 factors. First one is charge, or we can say electronegativity of atom, and second one is distance between these charge from their center. Predominant factor here is charge electronegativity difference, and more the electronegativity difference between two bonded atom, more the value of dipole moment. Means electronegativity difference, if it is increases, dipole moment also increases. And among these halogens, which one is more electronegative? Fluorine is more electronegative, hence its dipole moment is the highest one. Then of HCl, then HBr, and least dipole moment is of HI. Okay, if two factors opposes each other, then the result is according to the electronegativity difference. As in this case, if we discuss about electronegativity difference or the electronegativity, then it is fluorine is more than chlorine, then bromine, then iodine. It means HF have more electronegativity difference than HCl, then HBr, and least electronegativity difference between HI. But if we discuss about the distance, then it is more in HI, then HBr, then HCl, and HF. In this type of case, give the preference to the first point, that is the charge separation. Now next type is polyatomic molecules which have more than two atoms. Then first one is of AB2 type. In this we will taken the example of BeCl2 and CO2, C2H2. Then to calculate the dipole moment or to identify the polarity, first one all we have to draw their structure. For example, BeCl2, then its structure is linear. So there are two bonds in BeCl2, hence it has two dipoles. Dipole from less electropositive to more electropositive, and similarly in other bond from less electropositive to more electropositive. See, both the dipoles having same magnitude, as both the bonded atom are the same, hence the magnitude of dipole moment of both the bond is also the same, but direction is different. If one's dipole moment is with positive sign, then second with the same value but with a negative sign, hence what happen, both cancel out each other and make the overall, that is called as net dipole moment of molecule, it is equals to 0, isn't it? Similarly in case of carbon dioxide, in which carbon is double bonded with oxygen, what is the direction of dipoles of these two bonds? From carbon to oxygen. Here is also from carbon to oxygen. Direction is different, magnitude is the same, hence they are also cancel out and mu it again comes out to be 0. In case of C2H2, then here is the structure C triple bond C. Okay, now here is also, as carbon it is the triple bonded, it is more electronegative than hydrogen, and the bond dipole direction is from hydrogen to carbon. Here is also from hydrogen to carbon. Direction is different but magnitude is same, hence cancel out, and here is also mu is equals to 0. Okay, so here we make a result, that is, if polyatomic molecule, if it is non-polar, then condition for it is, if it is symmetric, that is central atom has no lone pair. Second, surrounded atoms are same or no lone pair on central atom, then mu for such type of polyatomic molecule, it is equals to 0, and molecule is non-polar. So to discuss the polarity in polyatomic molecules of AB2 type or any other polyatomic, we first see these points in the molecule, either it is symmetric or not. If it is symmetric and if it is surrounded by same type of atoms, there is no lone pair on central atom, then molecule is non-polar, as its dipole moment comes to be 0. But if any one of the given points is not satisfied by the molecule, then for it mu is not equal to 0, hence molecule is polar. For example, if we have here H2O, if we have H2O, then first of all draw its structure, then oxygen is bonded with hydrogen, and oxygen is surrounded by two lone pairs. So for the condition of dipole moment, that is equals to 0, there is no presence of lone pair on central atom, but here oxygen having two lone pair, also its geometry is not symmetric, it is unsymmetrical, hence for this molecule mu is not equal to 0, hence it is polar molecule. Remember one more point, the lone pair present on central atom also have direction from atom toward lone pair. Suppose this one is the atom and it is the lone pair, so its direction of dipole is in the direction of lone pair. Okay, this is the direction of lone pair. So the next type is AB3. For example, BF3, BBR3. So first of all, similarly, Draw the structure of these molecule and make the dipole from less electropositive toward the more electropositive. These two lower bonds point out in downward direction, so if we calculate their resultant, it is overall in the downward direction with the same magnitude as the upper bond. So this is like this. This one is the one dipole and this is the resultant of two lower dipole. Different direction, their magnitude is the same. If its mu is with positive sign, then its mu it is with a negative sign, but the value is the same, hence both cancel out each other, and here is also mu is equals to 0. Molecule is non-polar. Similarly, if we compare the dipole moment of SO3 and SO2 to identify which one is polar and which one is non-polar, then draw their structures, as this one is the SO3 and this is SO2, making the dipoles like BF3. Here also these two dipoles pointed out in downward direction, then their resultant have the same value when it calculate as this upper dipole have, but with opposite sign, hence cancel out. Mu is equals to 0. So SO3 is non-polar, but in this case the dipoles, as they also have the same direction, but their value is not the same. When its magnitude is calculated, then the value of dipole moment of this bond is not the same of this one. It means its mu is not equal to 0. Hence molecule is polar molecule, isn't it? So calculate yourself, identify either these molecules are polar or non-polar, that is H2O, NH3, CH3O, CH3. Okay, so this one is the first application of dipole moment. Rest of the applications we discussed in next lecture.